Fine, guys, let's start. So yesterday we have seen a few functions like filter, sort, okay, filling null values, etc., right? Fine. So today we'll start with something called as group by. Okay. So in pandas, okay, you can perform group by the keyword called as group by. Okay. So what is group by? It will just group according to different columns and it will give you the required columns as the output. Okay. For example, see here what I'm doing in this Titanic data set. Okay. So I am grouping it by, so I want to extract sex and P class passenger class columns. Okay. But in a way such that it should be grouped by the column sex. Okay. And I also want the mean. Okay. So if I run this, if you see here, in this column there are like two categories, okay, because I'm grouping by this column. Okay, when I'm grouping by this column, so what does this column is has, like, what are the unique values in this? So it is having two, male and female. Okay, so the whole data set will be grouped according to the unique columns whatever you are giving in this group by column. Okay, the sex column is having two unique values, male and female. Okay, so that will be mentioned over here. Okay, in that what column you want? I want P class column. Okay, so but if you see P class column, that is fine, but you should also mention what output you want for the P class. Okay, because what do I mean over here is, if you see here, the only group by, okay, the only group by, when you do only group by, so it will be a pandas function. Okay, so you cannot see any output. Okay, so you cannot see any output because along with group by you should always mention some statistical function. Okay, whether mean, minimum, maximum, anything. Because in other words, what we are saying, I'm saying group by this particular column and show me this column. Okay, but when I show this column, so it cannot show the all the values of this column. So you should mention what type of mathematical function you want to perform on this. Okay, so that is the way you need to perform group by. Okay, so only group by will always be an object function, so you cannot see the value over here. Okay, so you need to loop through it or use some statistical function on top of this to see some values. Okay, so now when I say mean, okay, so this means that it has grouped the whole data frame into two, male and female. Okay, and in this female, so what all the values we are having in the P class, like 3, 2, 1, the mean of those P class are this. Again, it has filtered complete data set with only male. Okay, in that male data set, this P class, the values of P class, only male filtered dataset P class. If you take the mean, that will be this. Okay. Yeah, are you getting, guys? See, even so, for example, if I mention some age, okay, so even if I mention age also, see, so the average age, okay, the average age of female is 27. Okay, from we did not do any filtering. Okay, from the complete data set, the average age of persons is 30. Okay, the average age of the ladies is 27. Okay, so it is grouping on this particular column and giving the values for this column. Clear?
Yes, sir.
Okay, so along with this only mean, okay, you can also extend this to multiple functions. For example, if you see over here, I'm using the same function, but I want more than one statistical function. Okay, not only mean, I want mean and max and mean, whatever you want to take. Okay, so you can do even that. Okay, so here when you see this, so I'm grouping on the sex column. Okay, but on the P class column, okay, instead of only mean, I want mean and max also. So this is a mean and this is a max. Okay, so but since we can understand age column better, so let me do it on age. Okay, so as you can see, maximum the I would say the oldest person, female person traveling on the Titanic ship was 63, and 80 was the oldest guy. Okay, so if I see the minimum, um, does we have age as 0.75? Yeah, there is like 0.75. Yeah, so this might be a data entry mistake, but still, whatever the minimum value is there, our system will give you that. Okay, so see, for the male, it is 0.42. Okay, yeah, it's yeah. Ideally, it should not be like 0.42, but the data set is having some issues. Okay, but that's fine. That's the reason we need to perform some data pre-processing, cleanings, etc. Okay, but from the given data set, the minimum maximum values are this. Okay, so like that you can give minimum, maximum, standard deviation. Okay, everything, all the statistic formulas we have studied. Okay, so this is how you can do the aggregation. Okay, this is called aggregation, group by along with the aggregation part. Okay. Fine. So, okay. So today let's see few more pandas functions. Okay. Okay. Yeah. Before that, let me just quickly see whether we have discussed. We have discussed these functions, right? Can you please help me remember? Just filtering on the strings, data types, object, describe, float. Yeah. Midday, embark, fair. Yeah. We have discussed this in previous sections. Fine. So now, see guys, let's start with this. Okay. So see here, I'm creating a data frame. Okay. So how I'm creating the data frame? So observe here. So I'm saying pd dot data frame. Okay. I'm saying pd dot data frame, and there is a column A, and these are the three values of A. Column B, and these are the values of B, and column C. Okay, and these are the values. Okay. This is a data frame. And what I'm saying here, if you see here, df of states, what is this? This is, I'm creating a column for the data frame. Whenever you say df, because df is my data frame, and when you say some value over here, like column 1, okay, that means you are creating a new column in the data frame. Okay, you are creating a new column in the data frame. So what is a new column? CA dot split. Okay, split means what? It will split by the space. Okay, so a new column called as states. Okay, and that is created where it will have values CA Why? Because every column is having three values, like 1, 2, nan, 5, nan, 1, 2, 3, like that, three values. Okay, and after that, what I'm doing, I'm using this states column as my index column. Okay, in step number 2, states column is just one more column, but in step number 3, now states column became index column. So that's why you can see the states as index. Clear? But for example, if I just show you, if I just do this, see, if I comment step number 3, states column is just one more column and index is a general index like 0, 1, 2. Okay. But when I do this, we can use the existing column from the data frame as an index also. How you can do, just df.set index, specify the column you want to use it as a index. Okay. So I'm using states column as index, in place equal to true. That means make the changes to the existing data frame itself. Now when I do this, you can see the states column got used as a index column. And these are the ABC values. See 1, 2, 9, 5, 9, 9, 1, 2, 3. Is this step clear?
Yes, sir.
Okay. Next, this is a data frame. Now we'll understand like different functions. Okay. Some of the functions which you might have already seen, but still. Okay. See, from this data frame, okay, from this data frame, when you do df.drop na access equal to 0, okay, that means what? Access equal to 0 means rows, okay, and when you're just saying drop na, that means drop all rows wherever you have at least one na value. Okay, that means what? This one, this one. Okay, nv and az. Okay, let's refer these rows by this index. Okay, nv and az will be dropped. You will have only ca. Okay, so as you can see, only one ca. Cool, good. Next, when you see access equal to 1, okay, this is for the columns. That means what? Drop all columns where you have at least one na. That means what? A and B will be dropped. Only C will be given as output. You can see only C. Okay. So that is how you can just drop rows with NS and columns with NS. Next. Yesterday we have seen threshold factor. Okay. So when I'm saying df to drop access equal to 0, okay, but with a threshold of 2. That means what? So it should, to drop it, it should have at least minimum 2 NA values. Okay, minimum. That means 2 or more. If it is having NA values, then you can drop. But if it is having less than 2 NA values, you should not drop it. Okay. So over here, if you see, CA is not is having 0 and NV is having only 1 NA value and AZ is having 2 NA values. Okay. So AZ will be dropped and you will have CA and NV. Okay. Because threshold of 2. If you change the threshold to 1, NV also will also be dropped. If you have 0, that means what? It should at least minimum of 0 values. So any column, it should have minimum 0 NA values. Okay. So bring it as 2. AZ is having 2 NA values. So that is dropped. Next, if you see df dot fill NA, okay, value equal to fill value. So wherever you are having directly, it is filling all the NA values. Okay, so if you see, let me take a screenshot of this every time. Okay, that's fine. So if you see here, over here, I'm just saying df dot fill NA. That means wherever it will have NA value. So this will be completely filled with the whatever the value you are specifying. So I'm specifying fill value. Okay, so those it will be replaced directly fill NA without any condition. Okay. After that, what we are doing, you see df dot fill NA. Okay, value of dfa dot mean. Okay, filling values with the composed value. Okay, so how you are filling the values? You are not filling with some random string. Okay, but what value you are using? Value equal to, see here in place of value, you are saying df of a dot mean. Okay, df of a dot mean. Why? Because if you see here earlier, df of a, df of a is, so this is getting confused. Let me print my df over here. Okay, I'll just print my df here. So if you see, this is my df. So df of fill na, that means these values, okay, these values, na values, I want to fill it in a way such that the values will be df of a, that means column a dot mean. Okay, what are the column a? 1 2. Okay, and what is the mean of that? 3 by 2, 1.5. Okay, so fill all the na values with 1.5. So as you can see, what 1.5, 1.5, 1.5. Okay, so you're filling with a integer value, or let's say a number. Okay, so earlier you can fill it with some random string, or you can also fill it with some integer value. Okay, or some number value. Got it? So also you can also, for example, you are having a, right? So only this a column, if you want, okay, instead of filling all the complete data frame with column a mean, you can also fill only a value with its mean, b value with its mean, and c value with its mean. Okay, that means what? Instead of doing df of df dot fill na, you can simply do df of a dot fill na, dot fill na. And in the value, you can say df of a dot mean. That means only df of a column will be filled with its mean value. B will be filled with its mean value. Because instead of filling one column mean to the complete data frame, it is more logical to fill with its own respective means. Okay. But this is a way how you can fill with the mean. Okay. Or similarly, you can go for the median also. You can go with the mode also. Okay. See median and sorry, mode. But since I think this is not having any mode, you'll not get any value. Okay. So what mean you will get. Is that clear? Yes. Did you follow? Shall I repeat?
Yes, sir.
Filling by mean clear, right?
Clear.
Okay. Yeah, and this is actually the regular way how we fill. Okay, we don't fill with random strings. Okay, so we fill it by either mean. Okay, this is called imputation, guys. Okay, missing values imputation. So missing values are the NA values, and when you are filling with something, it's called imputation. Okay, so in interviews generally they question in this way. So they'll say, what are the imputations need to perform? Okay, sir, once explain filling with respect to mean. Mhm. See, Sirisha, here I am filling only column A. Earlier I am using, see, this value df dot a dot mean, whatever we get 1.5, that we are using to fill the entire df data frame null values. That means here, 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 okay, here, here, here. But why I should use a column null, a column mean value for B also? I don't want to do that. So I will, if you want to fill only A, so just say df of A dot fill NA value equal to df of A dot mean. That means first it will compute this mean value and it will use that to fill only A column null value. So you will have only 1.5. B is still null. Okay. So similarly, you can also do it for B. So B, if you see here, B is having two NA values and only one non-null value, that is 5. So the mean is also 5. Okay, so it will fill the 5 with these two values also. So as you can see, 5 5 5. Getting? Okay, fine. So after that, we'll go to next data frame. Okay, this is data frame, and here if you see, yeah, we are having three columns company, person, sales. And when I'm saying, I'm grouping it by company. Okay, I'm grouping it by company, this column, and my column is by company. Okay, but as I said, I will show you again. As I said, when I just group it by company, it will perform. But when I try to print this, whatever the group you are getting, it will be just an object. Okay, you cannot see the value. Okay, fine. So after that, that's why what I am doing, I'm saying by companies. Now this is a group function. Okay, group by function. On that, I'm saying mean. Okay, I'm saying mean. So when I say mean, see, when I say mean, first it has grouped this whole data frame with this company. That means what? You will see all the unique values from this company, like FB, Google, MSFT. Okay, and on top of this data frame, I'm going for the mean. Mean of what? So obviously all the what all numerical values, sorry, numerical columns you have, okay, it will perform mean of those columns. Okay, so obviously you cannot find out mean of this person column, so it will ignore this. Okay, you're having sales, it will give you the mean of this sales on group of on top of group by company. Okay, so that means what are you getting? So see FB, so first these two columns are grouped into one. Okay, FB. Now it is saying give me the mean of it. That means it will give the mean of these two. Okay, what is mean of these two? 296.5. Okay, so that we are getting over here. Similarly, it is grouping that MSFT into one, and the sales mean it is giving 232. Similarly for GOG. Is that clear? Okay. Simple group by. Okay. After that, as I said, instead of mean, you can also do sum. Okay. So it will give you the sum of the sales. So from overall data frame, FB company, that overall sales is this 593. GOG MSFT. Okay. Fine. After that, if you see now on df.group by company, okay, and it is saying describe, it is taking only FB column, okay, and you are doing the transpose. So don't worry, when you break this up, what is my DF? This is my DF. I'm grouping it by company. I'm taking only FB column, okay, I'm taking only FB column, and we are doing the transpose. See, df dot group by company dot describe. First, if you see this, okay, so I'm grouping by company, okay, and that means what? You will have three columns FB, GOG, MSFT, and when you say describe, it is giving to you the values. Okay, so for example, if you see here, what is this mean, right? 296, 160. The same thing you can see here, 296, 160, 232. Okay, so when you say describe, it will give you everything. Okay, so this is a describe of what? Group by company. Okay, group by company, you are using describe. On top of this, okay, now you have this. Now this is also a data frame, fine, where the index is company and the indexes are FB, GOG, MSFT. Agree? And these are the columns. Sorry, sales is a column, and these are the its describe functions. Fine. So now when this is a data frame, obviously you can also use LOC functions on top of this. Okay, you can apply row extracting. So I'm using dot LOC FB. I want only this FB row. Okay, I want this only FB row. So that's why what I did, I'm using this. Okay, now when you see, this is a value I got. Okay, so when you do transpose, it will just give you in this format. Getting? So you have grouped into a column. Okay, you have grouped. So you are grouped by a particular column company, and for individual company you can try to understand. Okay, for here suppose I will say only for LOC GOG. Okay, so it is giving you, if you say GOG, yeah. So it is saying for GOG the mean sales are 160. Okay, two sales have happened. Okay, this is standard deviation, minimum sale is maximum sale, etc, etc, etc. Is it clear?
Yes, sir. Clear.
This is also same. Okay, and you can extract multiple columns also, simple. Okay, so you are grouping. Okay, in the place of LOC instead of one you can use GOG MS50 also. Okay, two columns, cool, fine. So that is regarding the group by. So in group by, what we have seen, normal group by we have seen, aggregate group by we have seen. Okay, so what was aggregate group by? Like you can use multiple statistical functions. Just give me a second. Where was that? Yeah, so you can use multiple functions using aggregate, or you can use only simple group by. Okay, on top of that, once you have that, you can also use describe, and you can perform .loc. Okay, just remember, simple group by will not give you any output. You should again use with some other function. Okay, fine. Next we have called, we'll see playing with two data frames. Okay, like merging, concatenating, etc, etc. Okay, so first of all, let's create few data frames. Okay, see the way how we are creating data frame is pd dot data frame a b c d. Okay, a b c d, and these are the columns and indexes 0 1 2 3. Okay, simple. So I'm running this. This is my df1. Okay, and this is my df2, and this is my df3. Okay, now we are printing df1, df2, df3. That's fine. Now there are different ways how you can, add is not the right word. Let's say merge or join or concatenate. Okay, or put together these two data frames. Okay, the first one is concatenation. Okay, that means just take one data frame and add it to another data frame. That means just literally put it beside or below or on top of it. Okay, just putting two data frames side by side. Okay, so for that we are using concat. Okay, so when you say pt.concat, I'm saying concat, and inside that I'm giving a list of data frames. Okay, df1, df2, df3. Okay, so once I do that, if you see, when I print my dfcat1 concatenation 1, okay, something interesting you will see. So it has considered this df1, okay, df2 and df3. Okay, and what it has done, it has just, this is df1. Okay, it has just kept df2 over here, df2, and just df3 over here. Okay, it will do just that. See, 0 1 2 3, this is df1, again 0 1 2 3, df2, and 8 9 10 11 df3. Are we correct? See, 0 1 2 3, 0 1 2 3, 8 9, or you can go by the values. A 0 1 2 3, 4 4 5 6 7 8 9 10 11. Okay, see. Yeah, so till here df1, df2, df3. Okay, but here if you see the indexing, right, it will have index repetition in concatenation. Okay, so why? Because the complete data frame, see, till here it is just the df1. Okay, on top of this, I mean just below it, it has just added df2. See, the index is again 0 1 2 3. Okay, here df3. Okay, if you see, index gets repeated over here. Why? Because see, here having 0, again you're having 0. Okay, 1 1 2 2 3 3. This is different, 8 9 10, but the some indexes are repeating over here. Are you following concatenation?
Yes, sir.
Okay. But here, when you do this, after that, but anyhow, whatever it may be, this is one, it is also a data frame. Okay. Concatenated data frame. On top of this, now if you see, when I'm saying dot LOC, see, I'm just using dot LOC of 2. What is this? Row extracting. I'm extracting the row. That means what? This is not ILOC. This is just LOC. That means it will search for the exact value called as 2 from the data frame and it will extract those rows. You remember, right, yesterday? So wherever the index is having 2, exact value 2, those rows will be extracted. Wherever you are having, see, this is 2, this is also 2. Okay, that means A2, B2, A6, B6. These two got extracted. Getting? That is, I think you can understand LOC better now, because wherever you're having 2, it will extract all those. See, it will just match with the, it just need the value 2 in the indexer. 2, 2. It got extract 2 rows. But when I do ILOC, now this will become index. This 4 is now index. That means what? Fourth index. That means fourth index row. This is 0. This is 0. This is 1. This is 2. This is 3. Now this is 4. Index 4. It will start 0, 1, 2, 3, 4. Now A4, B4. A4, B4, C4, D4. That will be extracted. ILOC index. But LOC, direct the value matching. Getting? Not getting. No?
Once
Repeat.
explain ILOC.
ILOC is just index, Srisham. See, these are the index, right? These are the indexes. When you say I, it is just index. It doesn't matter whatever you are having. It will just consider starting index with 0. This will become 0, 1, 2, 3, 4, 5, 6, 7. Like that, it will consider. When you say I index, so whatever with the values you are having over here, but the index value of this is what? 0, 1, 2, 3. Here, the index value of this is what? 4, because it's at the 4th place starting with 0. Okay. The index value of this is what? 5, because it's at the 5th place. Getting?
Okay, sir.
Yeah. So this, even though there is 0 mentioned over here, but what is the index position of this 0? That means this particular row. This row is at which position? 0, 1, 2, 3, 4. Fourth index position is this. Correct? This is 5th index position. Correct? So when I say ILOC of 4, that means this particular row will be extracted.
Yes, sir.
Okay, fine. So that is regarding the concat. Okay. Now this is by axis equal to 0 means rows concatenation. Now when you say axis equal to 1, it will be a column concatenation. Okay. So it will just put ABCD. This is DF1, DF2, DF3. Okay. DF1, DF2, DF3, axis equal to 1 means it will put side by side. Okay. And but here you need to observe what happens over here is indexings, right? So wherever you are having indexing, okay, so that will be treated a bit differently. Okay, let's try to understand that. For the column, for DF of 1, okay, for the DF of 1, it is having indexing 0, 1, 2, 3. Okay, it has it will be till this point. And for DF2, the index is again 0, 1, 2, 3. Did you notice that? See, for DF1, the index is 0, 1, 2, 3. Index, sorry, DF2, index is again 0, 1, 2, 3. But for DF3, the index is 8, 9, 10, 11. Okay, just notice this. Now come back here. Over here, if you see, okay, over here, if you see, If the indexes are same, that's fine. That's why this df1 index is 0, 1, 2, 3. Till here it's fine. For df2, the index is again 0, 1, 2, 3. So that's why it is putting it in the same row. Okay, till this part it is good. Okay, but now for the df3, the index is 8, 9, 10, 11. Okay, so it cannot put over here because the indexes are different. So it is creating a new index 8, 9, 10, 11. Okay, for df3, and it will put df3 values over here. Okay, but the remaining values for this index for df1 and df2 will be NaN values, because these indexes are not present for df1 and df2. Okay, but to create the complete data frame, okay, so obviously it should fill with the NaN values. Okay, similarly for df3, that means for these values are not present at this index like 0, 1, 2, 3. So it will put NaN values for here. Okay, that means what? Indexes it will not touch. Okay, so wherever you go, whether you follow the row approach or column approach, the indexes will be same as from the original given data. Okay, so here the values, these values are from the index 0, 1, 2, 3. But if the indexes are same, then it will concatenate side by, because df1 having 0, 1, 2, 3, df2 is also having 0, 1, 2, 3 indexes, so it can use it in the same row. Okay, same row. But the indexes for df3 are different, so it will create new rows with that index, and it will put the values over here. Okay, because these indexes, the indexes of these are 8, 9, 10, 11, so it should use only 8, 9, 10, 11. The remaining values will be filled with NaN, 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 NaN. Is this clear? No? Repeat, shall I? Okay. See guys, what I'm saying over here is when you're using access equal to 1, okay, when you're using access equal to 1, it will concatenate by column wise. That means it will put side by side. Okay, when it is putting side by side, it will take care of the indexes. Okay, first df1 abcd, okay, 0, 1, 2, 3 indexes, it's fine. Now coming to df2, it is also having the same index 0, 1, 2, 3. That's why it is able to concatenate it this way, just side by side. Okay, now for df3, the indexes are not 0, 1, 2, 3, 8, 9, 10, 11. So that's why it cannot put these values over here. Over here, it cannot put these values because the indexes will become 0, 1, 2, 3. It cannot do that. So it should maintain the same indexes. So that's why it is using 8, 9, 9, 10, 11, 8, 9, 10, 11. Okay, so it can have same, we cannot put these values over here. Okay, so that's what will create these indexes. Okay, now these values, these values are created. But to fill the complete data frame, it will fill up with NaN values. This over here, because these values are not present with this index, these values are not present with this index, and these values are not present with this index. Okay, getting?
Yes, sir.
Yeah, because if you see over here also, what is Sirisha saying? The index of df1 and 2 same, so it came beside. If I consider 4, 5, 6. Yeah, because yeah, so over here also, yeah, this is row concatenated. Yeah, so over here, if you see df1 and df2, correct, Sirisha? df1 and df2 indexes are, sorry, ABC, df1 and df2 indexes are same, so that's why you are able to put them side by side. Is that your doubt?
Yes, sir.
Yeah, if you consider 4, 5, 6. Yeah, if you consider 4, 5, 6, if you use 4, 5, 6 for df2, then it will have df1 over here, df2 over here, df3 over here. If you have 0,
The
1, 2,
diagonals. It come in the diagonal answer, I think.
yes, yes. So I'll show you it. So for example, okay, just consider df2. Okay, for gf2, instead of 0, 1, 2, 3, I'll say 4, 5, 6, 7. Okay. So now I'm using 4, 5, 6, 7 for this df2. Now if I run this, you see, this is df1 with index 0, 1, 2, 3. Okay, but for df2, this it is 4, 5, 6, 7. So it will, because the indexes are different from df1, it cannot put it over here. So that's why it is creating new rows. And for df3, it is again new index 8, 9, 10, 11. So it's putting in the new rows, and remaining values will be none. Clear?
Yes, sir, got it.
Okay. So, but if you have the same indexing, okay, for example, if I just show you, if you have the same indexing, df2 and also df3, okay, so now everything can be put in the one single row because indexes are matching. Okay, I hope that's clear.
Yes, sir.
Fine. So, but yeah, so let's go back to the original. What was that? 0, 1, 2, 3, 0, 1, 2, 3, and this is 8, 9, 10, 11. Okay. Fine. Okay. So now this is data frame, and after that, what we're doing, fill any value equal to 0. Okay. So as you can see, you can give any value, string or this value or mean value, median, any statistical function, anything you can use. Okay. I'm giving 0. Okay. So that means all these 9 values. Okay. So all these 9 values are filled with 0. Okay. Simple. After that, yeah. So that's it. Now coming to merging. Okay. So coming to merging. So I'm creating two data frames, left and right. Okay. So this is my left data frame. Key A, B are my columns. Okay. Sorry, key A, B are my columns, and these are my respective values, rows. Okay. And right is my another function. Okay. So this is my left data frame. This is my right data frame. Okay. So now this is similar to, I would say, SQL functions. Okay. So where you have what do we say, where you join two data frames, right? So this is almost similar to that. Okay, so let's try to understand this. Okay, so left data frame, right data frame. So over here I'm saying pd dot merge. Okay, merge is a keyword which you can use to merge two data frames. What if I need to, what is saying, if I need to fill the value 0 with mean, is it possible? Because it is in the string format. What's it, Risha? I need to fill the value 0 with mean. What mean? I didn't get you.
No, so in the previous we calculated mean also for the numeric values.
Mm,
We fill the
um,
NaN values with the mean value.
uh-huh.
So here the strings are there, no, so A, B, and B, D.
Mm-hmm.
For this it is possible to fill as NaN as a mean value.
No, but there are no, these are all strings, right? So you can calculate the mean.
Yes, but it's ASCII values we can consider, no. In that scenario, I'm asking.
I don't think it will consider ASCII value, but still we'll see.
Okay, sir.
No, it's still taking the NaN values only, Sirisha. So if you see A, first of all, what is this value? It's nothing. Okay, so you're having a empty list when you do df of a dot mean.
Yes, sir.
Okay,
Yes. Is this possible? Can I convert that A0 as ASCII format, sir?
yeah, you can convert, but why? It is not a number, it is a, what do you say, string, right? Some A0, A1, A2. Okay, why you want to convert it into ASCII value and then use that value and fill the remaining 9 values? Let's say you got, see what I mean here is, if you are having A0, A1, A2, A3, okay, these are 9 values. Okay, but if I ask you to just guess what values this could be, okay, this could be more probably some A3 or A4, so or A0. Okay, but these are having less probability to be some numbers. It cannot be some 5 or 6. Getting? Because the remaining values of these are strings A0. So this will also be somewhat similar to that, rather than some integer value or float value. Getting?
Yes, sir. Got it.
So you can do that. You can use the ASCII value from this and you can definitely convert that for sure. Okay. But I don't see that will help you to replace. But I think is you can go by the mode. Okay. Usually, right? Usually when you have the missing values, so we replace it by the mode for the strings. Okay. So for example, if I go by the mode, um, mode of A. You have cat of A dot mode 2, 3. Okay, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. Okay, you're having 3 A. Okay, so that's why it is giving you this way. Fine, I'll show you an example. So where you can usually when you are having categorical values, right? So instead of going by mean or median, you can go by the mode. Okay, fine. So let me come back here. Where are we? Mids.
Yes, sir. Much
Okay.
mentioned.
So left data frame and right data frame, and here you are merging left and right. Okay, you need to specify data frames. Okay, how? Inner. Okay, it's like kind of inner join. Okay, and on what column you want to? Key column. Okay, so it will search for this key column. Okay, it will search for this key column and it will try to match on this with inner join. That means what is inner join? Only when the matching rows will be extracted. Okay, so wherever you are having the match, okay, left and right. For example, K0 is matching. Okay, K0 is matching. You will have the K0 row and K8, but there is no K8 over here, so K8 will be skipped. K2, you are having yes K2, so K2 will be present. K3, yeah, K3 is also matching. So from here K8, there is no matching over here, that will be skipped. From here K1, there is no matching over here, so that will be skipped. So only K0, 2, 3 will be extracted. Okay, so as you can see, K0, 2, 3 will be extracted. Fine. And after that, when we are merging, see how it's merging. So from for K0, okay, for this K0 row, this is a K0, this is a K0. Okay, that is key is K0. And AB A0 B0 is from this data frame. Okay, AB A0 B0. Okay, and for the same index, what is index K0? It will put the values of C0 D0, C0 D0. Okay, so these two rows will be added over here. because K0 is matching. Similarly for K2 and K3 also. K2, K3 also, it will put these values over here. Okay, but this is different from concatenation, because on concatenation we are not using any functions. There is no matching key, there is no key parameter. Okay, it will just put two data frames side by side, or top bottom, or left side by side. Okay, but here merge, you are going by the index. Okay, you are going by the index, and on a specific key you are merging. Okay, and also over here in the concatenation, when you see, since you are not going by any key, so that's why there was an issue of getting multiple indexes, like you are having 1 1 2 2. Okay, multiple indexes, because it is just concatenating, putting one on top of other. Okay, but here, since we are going by the particular key, so there will be no repetition of the indexes. Okay, because for the same index, it will merge all the different data frames and you put it in a single row. Okay, fine. Okay, is this clear, the merge part?
Yes, sir.
Yes, sir.
Okay, so after that, what do we have? Yeah, so this is the data frame, left, right. Okay, so merge is I'm merging on key 1 and 2. Okay, so you can use multiple keys to merge. Okay, so key 1 and key 2, these two columns I want to use to merge. Okay, so key 1 and key 2 in this data frame, in the left data, this is left data frame, this is right data frame, and key 1 and key 2 are over here, key 1 and key 2. Okay, so it will use now combination. So K00, sorry, K0, 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 K0. Do we have K0, K0 over here? Yes, we are having K0, K0. So K0, K0 row will be extracted. After that, K0, K1. Do we have K0, K1? No. So since there is no match, this will be skipped, K0, K1. Okay. After that, K1, K0. Yes. K1, K0, there are two rows. Okay. So you will have K1, K0 for sure. Okay. This is done. And K2, K1. No, there is no K2, K1 over here. So this will also be skipped. Okay. So now coming to K0, K0. Okay. See guys, follow here. Coming to K0, K0. So this you're having K0, K0. This will be matched, and A0, B0, C0, D0 will be extracted. See K0, K0, A0, B0, C0, D0. This is fine. After that, K0, K1. K0, K1 is not present over here. Okay, this K0, K1. So this will be ignored. Okay. After that, you are having K1, K0. You are having two K1, K0s. K1, K0, K1, K0. Okay. A2, B2. Okay. K1, K0, C2, D2. Sorry, C1, D1. Okay. So it has found two matches, because this K1, K0 is appearing two times. K1, K0, K1, K0. So first it will take this A2, B2 with C1, D1. And again A2, B2 with C2, D2. Because this key is matching two times over here. K1, K0 is repeated two times. Okay, this is done. After that, K2, K1 is not present over here, so this will be skipped. And K2, K0, it's not present over there, it will be skipped. Okay, so finally, if I just map it, what is happening? So this K0, this is mapped to this. Okay, and K1, K0 is mapped to this K1, K0, and also this is also mapped to K1, K0. Two rows are matching this. This K1, K0, K1, K0 is matching, and also K1, K0 is matching. Is that clear, guys? Okay. Fine. So after that, similarly, this is direct match, that merge. Okay. But in SQL, if you no, you will have left join, right join, left. Okay, so inner, etc. So if you see left, okay, that means what? It will give all the values whatever it had from the normally it will perform inner join. Okay, left means what? It will consider all inner and also the left column rows. Even though it is not matching, it will also give the values from the left. That means all the rows from the left will be given as a, you can see them in the output. Okay, so for example, if you see here, okay, left, in the left, what rows are not matching? K2 K1 rows, K2 K1 there is no match. Okay, and also K0 K1, K0 K1, for these two rows there is no match. Agree? But here those are skipped because by default it will, if you don't perform any, if you don't mention any how parameter, it will consider as inner. But here if you specifically mention how is equal to left, right, so then it will give all the rows from the left data frame. Okay, so as but it will use the NaN values. Okay, so this is just what rows we are seeing over here. Okay, those are exactly the same rows over here, but these two rows are from the left data frame, which is not having any matchings in the right data frame. That's why these values are NaN values. Okay, these are NaN values. Similarly, when you do right data frame, when you do on right, so all the rows from the right will be used. Okay, that means if you see all the rows from the right, this will be used. Okay, but here wherever you are not having a match with the first data frame, okay, for K2 K0, okay, for in the right data frame K2 K0, there is no matching in the left data frame. Okay, that's why for this row it will be NaN values for left data frame. Okay, K2 K0, the NaN values for the left data frame. Okay, so simple, it's not as complex as it might seem. Okay, so just SQL joins sort of thing. Okay, so right means it will consider all the whatever the data frame you are mentioning over here, right? So it will make sure all the rows from that data frame will be shown in the output. Okay, if there is any match from the other data frame, it will match, or else if it is not matching, it will just give you the NaN. Getting? Hmm? Okay. Okay, so after that we have join operator. Okay, so if you see left and right, these are the columns left and right. Okay, and left dot join. Okay, left dot join right. Okay, so wherever the rows indexes are matching K0 K1 K2, so it is just joining. Okay, K0 A0 B0, okay, and C0 D0. Okay, so for K1 A1 B1 there is no matching, so that's what we put as NaN. Okay, and for K2, okay, it is using A2 B2, and for you're having C2 D2. Okay, so see here, and for K, since we are doing left, you are joining right, so it will consider the only the rows of left. If there are any matching, it will concatenate, otherwise it will leave it. Okay, but if I do it the reverse way, okay, so if I do it the reverse way, right, left, okay, then it will consider the rows from the right, K0 K2 K3. Okay, it will join with the K left data frame. If there is any match, it will use that. If not, it will ignore. Okay, so that's why if you observe, K1 is missing when you join with the right. Okay, because in the when you are saying right, it will give preference to only right column, right indexes, right data frame index, K0 K2 K3. It will use only these. Okay, K1 it will skip. But when you are using left join dot right, so it will give preference to the left data frame indexes, K0 K1 K2. K3 it will ignore if it is not, because it is not present in the left data frame. Okay, And similarly, you are having left dot join right outer, it will consider all the columns. If you do outer, it will use all the complete 2 data frame columns. Okay, fine. So that's regarding mainly the concatenation merging part and the join. So out of this, I would say merge will be the most important thing. Okay, merge, you try to understand it in a better way. Okay, fine. So after that, we are having just few this merge we have discussed, but there is one important function I would like to discuss. Okay, which is called as apply. Okay, so these are all sort values, fill in. Yeah, we have discussed all this. Okay, yeah, one last thing for today we need to discuss is very important thing called as apply. Okay, you guys there?
Yes,
Yes,
sir.
sir.
Okay, okay, see, focus here guys. Apply function is the most important function. Till now what all functions we have studied, right? So apply is you will use like almost in every project. Okay, so and it is very helpful. Okay, so just focus here. Okay, don't miss this. See, apply function, so apply function is basically, okay, is used to create a new column. Okay, create new column from existing column. Getting? See, I'm simply creating this data frame, this column 1, column 2, column 3, and this is a data frame I created. Okay, so now using this column 3 or 2 or 1, okay, using the existing column, if I want to create a new column, okay, give any column, let's say column 4. Okay, if you want to do that, and using some other, let's say column 1, I want to create new column called as column 5. Okay, you can use apply function. Getting the idea? So you can just take any column, okay, pass it to this apply function. Okay, apply pandas function. Inside this apply, you can write any function you want, it will make the required transformation, and then it will create the required column. Getting? I'll repeat again. You see, for example, we are having this 1, 2, 3, 4, 10. Simple example is I want to multiply each value by 10. Okay, and create a new column. Okay, so take this column, pass it to the apply function, pandas function. Inside this apply, you write whatever the transformation or the calculation or changes you want to make inside a function, or you can write directly also if it is a small thing. Okay, or if it is a big thing, you can write it in a function. Okay, so each and every value will be passed via apply to this function, and the output will be generated, and it will be it will be all, once you do it for all the values in this column. Okay, and you can give some other new column name that will create a new column with the transformations happened. Okay, we'll see with an example, don't worry. See, for example, this is a data frame, simple data frame. Over here, observe carefully. I am creating a new column, function applied column, because there is no function applied column. We have only column 1, 2, 3. I'm creating a new column called as function applied. How I'm creating? See, this is important. I'm taking this df call to, that means what? Column 2 I'm taking from df data frame column 2 dot apply. I'm applying. Inside this apply, you can write any function. Okay, you can write actual user defined function like def, or if it is a small thing, you can use a lambda function. I hope you remember lambda function from our Python sessions. Okay, so inside this apply, I'm using a lambda function. Okay, and this is a function. What it is doing, whatever the value x you are giving, it is applying a logarithm of that, and it is returning the log of that particular x. So from where you will get this x, this df call to. Okay, so using this df call to, you are passing each and every value from this df call to this apply. This will pass it to lambda x, and that x will be going over here np.log x, and it will calculate the logarithm of that each and every value, like 444 logarithm, and it will return. Okay, so this is a value. So 444 logarithm log of x is this 555. This is x. So you have created a new column called as function applied column. Okay, for example, if it is confusing, I will say log column. Okay, so see, log column, you create a new column. How from the existing column only you applied some function on top of this and created a new column. That is the use of apply function. Very, very helpful, very useful also. Many times you want to create new columns. Okay, so many times from the given columns you want to create new columns or split or create new columns. Okay, in that case apply will be very handy. Did you get this apply example?
Yes, sir.
Pakka. Okay, one more simple example. See what I'm saying, you're having this column 3. Okay, I want to just calculate the length of these columns, length of each and every value in this column 3. Okay, like 3 2 1 like that. Okay, so what I'm doing, simple, df dot column 3, I'm creating a new column. So df of this, you can give any name over here. This is the name with which a new column will be created. Okay, how it is creating df of column 3, that means I'm taking column 3 dot apply length. Simple length function we are applying, so it will calculate the length of each and every value, and this with this name a new column is created. Already this function column is created in the above. Okay, we have replaced it anyhow, but this is already created. But now column 3 length column is created, and this, see the length of each, and see the length of this is 3, length of this is 1, length of this is 4. A new column is created from the existing column. Clear?
Yes, sir.
Simple, right? Okay, so similarly you can also do square root. Okay, see on this function also, see function applied is the column which we have created. Okay, on top of that again you can apply function, getting from this column 2 we have created this function applied. Okay, it is replaced to log column, but actually it is function applied column. Okay, from column 2 we have applied log, that will give you this values. On top of these values also again you can apply function, and here what I'm doing the square root. Okay, the square root of this is this, like that. Okay,
Okay, sir.
okay, and remaining that is you can use some mean, standard deviation, minimum value, maximum value, everything I think we have discussed. And see apply of length you can, okay, yeah, deleting a column. So okay, del will of df of call length will delete this. Okay, so deleting a column is simple, del keyword and mention the length of the mention the column. Okay, after that sort values we have seen. Okay, by column. Okay, sort by which particular column you want. By default ascending will be true. If you don't want ascending, then you can mention ascending equal to false. Okay, sort values we have seen, and head is null we have seen, fill na we have seen. Okay, and mids we have seen, and mids left we have seen, right we have seen, and outer we have seen. By default inner we have seen. Okay, so as you can see here 0 1 2 3 it is having, yeah, 8 9 10 8 9. If there is no matching with the indexes, then it will not give any output. Okay, so we have seen, I will share this notebook, you can go through it once. Okay, the meds we have seen. So regarding the apply function only, okay, regarding the apply function itself, I will show you a few more examples tomorrow. Okay, so because apply function is very important. Okay, so I think we have discussed, see guys, I'm taking few classes. Okay, I think this is 6th class for pandas, because you know, as I said, pandas is like a small ocean. Okay, so there are like lots of functions, but I'm just trying to make sure that we are not missing any important function. Obviously, as I said, we cannot cover all the functions, and it doesn't make sense to cover all the functions that is present in that pandas documentation. Okay, it will be not helpful. Okay, but what all the important functions are there which we use? Okay, so that I'm trying to cover as much as possible. Okay, so I think we have already covered all the possible functions. Okay, so right from like data extracting log, LOC, ILOC, okay, and the basic describe function, correlation function, fine, and fill any values, backfill, forward fill, okay. And what else we have discussed is merge function, concatenating, okay, join, okay, and group by, aggregate group by, okay, and filter and where, query. You remember these functions, right? And today most important, apply function. So I am hoping we have considered all the required functions, but however, I will make sure if there are any missing functions, so we will cover it tomorrow, okay, and we'll conclude pandas tomorrow, okay. So tomorrow you guys joining, right?
Yes, sir.
Okay, so tomorrow we'll conclude pandas, okay. So that we will have all the required functions will be covered, okay. So I'll also give you a list of functions, important functions, okay. So I think I already shared the PDF document, okay. So that seemed good. Pandas functions, okay, all the important functions, okay. You can go through that and ask me if there are any questions, but tomorrow I will also try to make a list of important functions and we'll discuss if there are any missing, okay. So I hope you are following the class, okay. So let me know if you have any questions, okay. Are we good? Okay, chalo. Thanks guys, bye. Let's meet tomorrow.